Hello everyone, my name is Sunny Kumar Sharma. I am a PMRF research scholar in IIT Kharagpur. Here we are discussing design of farm machinery NPTEL assignments, and today we will discuss week 6. Let's wait for 5 minutes, then we will start. So just NASA, have you solved all the assignments? Till where have you solved?
Sir, actually, I didn't know that it will be preponed, so I prepared myself for Monday. So I have a lot of doubts from first week itself. Like,
Okay. So
so can I ask now, or like after
yes,
solving this, we have?
yes, you can ask.
Sir, from lecture 5, there was a question on disc plow. Like, not from the assignment question, rather from the lecture video.
Okay, week 1, no?
Yeah, lecture 5.
Mm, what is now?
So there is a question. There is a numerical sir solved.
Uh,
So can you please explain that numerical itself? Because the first part I couldn't understand that one. And from the assignment questions, I have doubt from question 5, 7, 9, and 10.
Question 5. This right?
Yes.
Question 5. Then 9.
7. Like I am not sure with the options there. I think, sir, this was not in the like the assignment we got. Those are not the options in question 7.
9. Question 5 is in the 9, right?
We had, sir, 15 to 55-degree probably.
The most
So I'll
common
check.
disk angle in vertical disk, common disk angle 40 to 55. That is not the answer. See, what you are saying is C is the correct answer. No?
No, no. Actually, sir, the options we have in our assignment, no, it is different from this. I was saying
No.
that we had different options, and the correct options that was given, that one also I had doubts. Sir,
Actually,
I'll check it with the.
just I'm pronouncing your name correctly, no? Chisna, sir.
It's Jigyasha, sir.
Sorry.
Jigyasa,
Just
curiosity. Yeah.
okay. Okay. Okay, Jigyasa. Actually, what you are solving now, that is this year's assignment, and what we are solving here, that is last year's assignment.
Yeah, but sir, I had doubt in our assignment, like this year's current assignment.
Okay, this year's
It
assignment
has
we are
been
asking assignment.
given in question number 7. Here they have asked the most common
Most common,
angle in standard display.
most common tilt angle, no?
Yeah.
In standard display. Okay. And
Huh.
what is the answer? Oh,
The answer given here is 15 to 55-degree.
15 to 25. And what
No,
you
no,
wrote?
no, no. It's 15 to 55. 55.
Okay.
So I also
This
did the 15-degree, but that will be like 15 to 25. No, sir?
this will be 15 to 25, yes. And in your assignments, it is written 15 to 55.
Sir. Yes.
That is wrong. Wait, let me check. Actually, that's right.
I have jotted down all the doubts. So
Okay. Thank you for pointing this out. And um, you can sum up all those your doubts, like what you are telling now, that this transcript problem. Just remind me, I will go to NPTEL. That is serious issue, like that. If you are mis- mm, too much time to this.
Standardization of the notes, if that won't be there, like that will be problematic for the coming students as well.
Yes, yes. And what is that exact question of that week one that you are telling?
Well, that is question number 5.
From which week you are telling? A week some
One,
week.
one, one only. At least all
No, no,
questions are from
lecture
one.
number, lecture numbers. From the lecture
Lecture
you
number
are
5.
okay.
Lecture number 5, question 1. Like towards 15 minutes PDF of the assignment itself. Like that the date of assignment submission is over, they upload the PDF of the assignment along with the answers. So if with this course it can be provided, that will be helpful to like to form a note kind of thing, like to print out just
Detailed solution in other lectures you are being given detailed solution, and here you are not being given.
sorry sir, I couldn't follow.
Means in other NPTEL courses you are being given those detailed solutions, like solutions also. Is that so?
No, it depends. Like course to course, it varies. But after, like before feedback form and after assignment, there is a like a section in which they are providing the PDF. May it be a detailed solution or simply like compilation of all the like the correct options and the questions or whatever the course instructor wants. But there is something provision of a PDF.
Okay. You have noted all these things now. At the end of lecture, I will you just sum up all your technical these issues. I will tell them, like I will mail them that these are the issues students are facing.
If this can be incorporated, then it's good. Like it's not like I'm
That is okay.
planning or yeah.
That I understood. So that question six is this one. I'm sorry, that week five question. This that is has 11. This one you are saying.
So just I'll search. So you are not displaying the question, no? Like
That currently I'm checking on YouTube. I'm seeing.
so there's a question. A tandem type
Yes,
disc
yes, yes.
harrow has 11 disc of diameter 50 centimeter. That question.
Total wheel load in each bearing. Total thrust load on each bearing. Okay, Miss, I need to
Huh.
read this question. That this I have not solved here, like by discussing session. So in next class I will solve this question here. So whatever I have taught that question five, right now I will solve this question.
Okay, so lecture 5, I'll ask you in the next class.
That lecture five I will solve in the next class. That question
Okay,
because
sir.
I need to read that
Huh.
question. And here we are solving
Okay.
week six. I have noted
Huh,
it
sir.
down.
Sir, and like two more questions from the assignment one itself.
Okay.
So, sir, question number 1.
Question one only. Assignment one
No, no,
question
no.
one.
No, not question 1, sir. I have to like search from here. This is the problem. Actually, I have to go to the. No, I don't have the PDF, so I have to search from here. Sir, the uh, question number 9 and 10. They have this. Which of the following statements is correct?
Nine and ten. Mm.
They have said like two statements has been given that neither will be correct.
Huh.
Answer question number 10.
Question ten. What is question ten?
It's on disk arrow.
The resultant downward force acting on the gang of a disk arrow must act at some distance. Suppose this is disk arrow. This and here some thrust is acting. This weight, the resultant downward force acting on the gang of a disk arrow must act at some distance from the center to obtain uniform concentration. So what this weight will not act at the center. This should act at some distance so that this thrust force, whatever acting on the disk arrow, this will balance the weight moment. So that's this statement is correct. Yeah, correct. The weight should act some distance so that the this thrust is not acting. If this thrust would have acted at the center of this at this point, then weight will act at the center. If the thrust is acting below, like soil is being disturbed at this portion, so thrust is acting at somewhere else. So to balance that moment, weight is being acted at some distance. So first statement in case here is correct. The second statement is the convex end of a disk tends to penetrate deeper. So that will become incorrect because concave end, this is the concave end and this is convex end of the disk block. So this concave end, this side tends to penetrate. So this will become incorrect. So only one will be correct. That is only answer, no?
Yes, yes. Only one is answer. So first bit you can you please elaborate a bit, like explain again?
This carries then in next week, in week two, I have given a detailed like elaboration that how these forces act on the disk, like where the moment acts. Some all forces are there, a moment force, thrust force, this RH force, all these forces, how where they are acting. So this thrust force, this T amount, this thrust is acting at the core part of the disk arrow. So that this portion, that green portion at this part. So this thrust is acting and to bend this thrust is generating a moment on the disk arrow because it is acting downward. So it will try to rotate it, suppose this side. So but we need to balance this counteract this moment. So what will happen? This weight, suppose this weight will act at some not here, at some distance. So it will try to counteract it by rotating it some other direction. That statement has been written that the resultant downward force acting on the gang of a disk arrow must act at some distance from the center to obtain uniform penetration. And if this will not happen, then not penetration like this will not be uniform. That has been written.
Okay, sir.
That was next question. That was week five. Week question five. No? This one.
Yes, yes.
When px is in the direction of travel,
Sir, actually in the assignment this figure was only not given. Like it
in
was
assignment,
missing.
seriously.
Sir, I saw like I can share the screenshot if it's possible, but it was not there.
Okay, sir. You're sharing.
Yes, sir, I'm sharing.
Scroll down. Okay, I will tell this to sir. Hello. Mm, I saw. Okay, Jigyasa, you turn. You answer your question.
So we can
All
that
these
the
doubts.
figures
Yes.
are again.
All these doubts now what we are discussing here, you note it down at some paper. Huh? I will give you my email. You send those doubts. All your doubts on that mail.
So also week 2, 3, if like before the Monday, like next doubt clearing class
Mm.
happens, I can share.
Sorry.
Like I was asking that for week 2, 3 and other doubts, if I have compiled, then can I share it with you in the
Yes.
email?
Yes.
Okay, sir.
Uh, in this week, other than five questions, seven. What was other question? Five, seven, and
We are done with like first week.
okay.
I have like I've asked all my questions, so we can continue with the week 7.
Week six. Okay. Here, like in this week now, I thought that I will solve mainly numerical problems. So I have designed this PPT like that only. A seed drill, proper seed drill from scratch, like from beginning to all the seed matrix mechanism that I will solve. That will take one whole class. So here I will solve some numericals related to seed drill. So first question of that week, last year it was the type of metering unit used for precise dropping of seed. So do you have any idea what will be the answer?
So fluted roller.
Fluted roller is not for precise dropping. Fluted roller is for like um, bulk dropping of seed, and that is also not plant maintaining plant to plant distance. It is just for row to row spacing. So fluted roller will not be correct answer. Horizontal plate and cup type, these are also type of planter, but they are also not precise dropping. For horizontal plate, vertical plate, these are used in planter, but precise dropping of seed is done with belt type of metering unit. So belt type will be correct answer. Second question is in case of fluted metering unit, the feed rate can be varied with change in. These lectures you have seen, this is I think lecture 26. Have you got went through that lecture?
31st, I think. Like I have seen first 10 minutes of 31, so I think that was it.
Mm. Okay. In case of fluted roller meeting, the feed rate can be varied with change of rotational speed of fluted roll, outer diameter of roller, length of exposure. Rotational speed of fluted wheel will change the feed rate and length of exposure will also change. Have you seen fluted roller how it looks? Suppose this I'm making rough sketch. This will be a fluted roller. Here it will have some floats. It will be spherical. It will have some floats inside, groups inside, and here seeds will directly come. When it will rotate, seeds are coming from hopper, and it will directly come into these floats. So this is called length of exposure. This length. This length is length of exposure. Seeds are coming here, and this, and we can manage that at what length of exposure we want. Like this can be slided, and we can adjust this length of exposure. And this rotational speed we can also change to vary the feed rate. So correct answer will be both rotational speed and length of exposure we need to change to have so that feed rate can be varied. So here answer will be D. So these are some different types of openers. This you can that this will be there in your lectures also. Solid type, chisel type, soup type, donut type, single disc, double disc type. Seed metering has two aspects. So first is metering rate, second is calibration. This what I just now explained, this is called metering rate we can manage. And what is calibration? This that you have studied in BTech. What is calibration? What do you mean by calibration of seed tree?
With the proper length, like synchronization, we can say.
Synchronization can be a term like what we do in calibration, we meter that if suppose we have 10 kg per hectare, we need to we want our seed rate this field. So what we will do in at seed drill, what we will do that we will meter that we will calibrate that if in a fixed revolution, suppose 25 or 30 revolution we will take and we will see that are we able to achieve this 100 kg per hectare or not. Accordingly, we will adjust something like length of fluted roll or something, or the speed of the flow, or we will do some adjustment here so that we can achieve this 100 kg per hectare. That is called calibration. That we need to achieve this 100 kg per hectare or seed rate. So next thing is missing index, like performance index of seed drill. Missing index, what is this? Suppose we are dropping seeds in a field at some spacing s. So if seeds are being placed at a distance greater than 1.5 s, greater than 1.5 times of this spacing, that is called that that all will come under missing index. And multiple index is when when the seeds are being dropped at a distance less than 0.5 times of the spacing. Quality of feed index is between that 0.5 times and 1.5 times. These are all theoretical things. And coefficient of hill distribution uniformity and coefficient of seed dropping uniformity. These are two terms related to performance of seed drill also. So coefficient of hill distribution uniformity is used to measure the variability of seed to seed spacing. And coefficient of seed dropping is used to measure the variability in number of seeds dropped in hill. So these are the some of performance things. So with these questions will come. So suppose first question is third question of that week is multiple index of a seed drill is defined as. So just now I've said. So take the answer. Multiple index is the number of spacing between seeds. Those are this is multiple index less than 0.5 times or equal to. So the spacing of seeds between the spacing between the seeds those are less than or equal to 0.5 times the desired spacing. So B will be the correct answer. Next is variability of seed to seed spacing while carrying out sowing. See, variability of seed to seed spacing
Missing, um,
mm, while carrying out the spacing in factors determined by. So what will be the correct answer?
missing index. SC will be no?
SE will be there. Coefficient of hill distribution uniformity. SE. Now next question. Soya beans are to be planted in rows 75 centimeters apart to achieve a plant population of 4,30,000. per hectare. Assuming an average emergence rate of 85%, spacing between seeds in centimeter will. So how we will solve this? What is the first step to do here?
Row to row spacing, like number of rows per hectare, we can calculate.
Hmm. If you see now, I'm telling that you already have given gate. Gate is done. Hmm. So whatever next exam will come related to this farm scenario, this type of question will come. If you see that these are the plants per hectare and some emergency rate is given, so immediately you find that what is the plants per hectare in actual. So 4,30,000 plants are there and emergency rate is 0.85 divided by 0.85. That will be the actual amount of seeds we need to plant in per hectare. From here you will get that in 10,000 meter square, what is the number of seeds you are getting. So 4,30,000 by 0.85, what it will be.
So answer is God.
You got the answer. 0. This is 505,882. This will be the amount of seeds, this number of seeds to be dropped in 1 hectare. So in this 10,000 meter square, this much amount of seed and 75 centimeter is the distance between row to row. So what you can make a concept here that what will be the area which one seed will take. Can you think? Suppose this is row to row, a spacing of 75 centimeter. So what area will one plant take?
We can divide it.
Divided means, see from here we
Like
can get that
10,000 by 0.75.
10,000 by 0.75.
Yes, sir. That will give the meter of row.
That will give the meter of rows. Yes, that means whole length will come. And what after that?
Then the spacing will be, we can calculate from that.
Uh, that you can, that can also be done. So one seed will take 75 into this the spacing between two plants. Suppose S. So 0.75 into S. This is the area one plant is taking, and from here we can get it directly. That one plant is taking this much seed is taking this area. So one seed will take 10,000 by 505,882. This much area is being taken by one seed, and this area is nothing but this. So this should be equal. So spacing will come. That same thing which you are telling, that is also the same. From there you will get a row length, whole row length, and you will divide it by number of seeds. From there also you can get the spacing directly. But what sir will also solve this question in the lecture. That that method we will also discuss here. I've seen that lecture. What sir has done that I'll discuss here. So next question is, in a seed drill, single disc type furrow outlet is used for. This is direct question from the assignment, sir, lectures. So no concept here is there, like it is just single disc furrow outlet is used for drier areas. I don't know this year it is there or not. Next question, it is there. This is there in week, but it was it is very complicated problem. So I thought that I thought to discuss it here. Soya beans are to be planted in a precision planted that meters 54 seeds per revolution in 10 days. The row width is 75 centimeter. Planted speed is 7 kilometer per hour. The plant population is this much hectare. So what is the required seeding rate assuming a seed germination of 85%? So first section is what is the seed space? What is the required seeding rate? If 85% is the germination percentage. First thing what we will do for exact seeding rate, we need to divide this amount of seed by 0.84. That will give the required seeding rate. That should be the plants per hectare. Second section is the required seed spacing. Seed spacing.
It is 564705.88. Like we can take 6.
5, 6,
4706.
5, 6, 4, 7, 0, 6. Okay.
It's coming 5.88, so take it as 6 like.
Second section is what is the seed spacing. So what sir has done there, it is in 1 minute, what is the area that seed drill is covering? It is taking 7 kilometer, it is operating at 7 kilometer per hour, and it has a row width of 75 centimeter, means 0.75 meter. So what will be the area covered in 1 minute? 7,000 meter by 60. This will be meter per minute into 0.75. Can you do this? 7,000 by 60 into 0.75. Okay, we will leave it like this only. 7,000 into 0.75 by 60. This will be meter square per minute.
87.5.
Okay, this is 87.5 meter square per minute. And this much plants per hectare means 564706 in 10,000 meter square. 10,000 meter squares. This much amount of seed in 1 meter square. So 1 meter square, this much amount of seed. This will be 56.47. So what will be the amount of seed in 87.5 meters square? 87.5
4941.
multiply this two. So this will be
4941.
4941. Means what is happening here? 564706 by 10,000 into 7,000 into 0.75 by 60. You will understand that line thing like this. So this is the number of seeds in per minute. Now see how much that seeded is how much length that seeded is covering in 1 minute. That is operating at 7 kilometer per hour. So in 1 minute it is covering a length of 7,000 meter. 7,000 meter by 60 is meter per minute. What is this value? 7,000 by 60?
116.66.
116.66 meter per minute. And in 1 minute, this length has been covered, and in 1 minute, this amount of seed has been dropped. Yes, 4941 seeds in 116.66 meter. So what will be the spacing? 116.4941. This meter will be the answer.
0.023.
0.023 meter or 2.3 meter centimeter. Now, why I did that part, you see. This this divided by this number of seed. 7,000 by 60 divided by 564706 by 10,000 into 7,000 into 0.75 by 60. Can you see something? This part and this part. This will cancel out. And this is the emergence rate. And 0.75 is the spacing between two rows, but the spacing of the is the row width. So what is happening here? Same thing you can do directly. So what I'm trying to say is 564706 seed in 10,000 meter square. So one seed in 10,000 by 564706 meter square, and this much area divided by the area which one plant is taking. Suppose one plant is taking the spacing into the row width, that is 0.75. Means this will be divided by 0.75. We can get the spacing directly. This is the same thing which I explained in previous question
Like
also.
this, thing I've written in the last. Can you just explain again that in brown pen you have written now? Now, so just tell.
So this is the row width 0.75 meter or 75 centimeter.
So we don't have to do that completely. Rather, we can only
Yes,
use
yes,
this
we
in
can.
sort.
Yes. From here, one conclusion also we can draw. I will tell you. The one plant is taking 0.75 into S meter or something K meter or anything. That spacing into row width is being taken by one seed. So one seed is taking this area. And what is the total area taken by one seed? From this thing, that this much seed is taking 10,000 meters square. So one seed is taking 10,000 by 564706 meters square. This area is nothing but this area, same area. So 0.75 into S is nothing but that area, 10,000 by 564706. So spacing, what will be the spacing? 10,000 by this and by 0.75. So directly this is coming here. 10,000 will go up. 10,000 by 56706 into 0.75. So we don't need to course set us out like this. And this can be confusing, this whole thing. You're getting?
Yes, sir. You have to.
Actually, it is a bit confusing. If you see it this way, you can see that what is going on. So what we can conclude here is that there is no effect of speed. What we have studied in theory also, that speed has no effect on seed rate, seed spacing. So whatever will be the speed of seed rate, 7,007 km per hour, that is being cancelled out. Yeah. So that is not affecting the seed spacing. Whatever speed we are operating the seed drill, This will be the spacing maintained. With that concept also, we don't need to include this speed thing that you have seen. So seed spacing thing we have discussed in detail. The third question is third section is the required rotational speed of the metering device, RPM of metering device. We have an input or idea with how we can obtain this rotational speed. Rotational speed of the metering device. This is the metering device. What we know about metering device? So this implanted that meters 54 seats per revolution. In one revolution, it is dropping 54 seats. But we know other thing that how many seats are being dropped in 1 minute that we have calculated. In 1 minute, we written here. And at this part, we were discussing that in 1 minute, how many seats were being dropped. 4941 seats. 4941 seats were being dropped in 1 minute. That we were calculating. So 4941 seats are being dropped in seats per minute and 54 seats in one revolution. So what will be the revolution in 1 minute? This amount of seed by 54 will give number of revolution. Understood? This is the total number of seed, and in one revolution 54 seed. So total revolution is 4941 by 54 will be the total number of revolution. This will be total number of revolution and what we are doing in 1 minute. So per minute. So this will directly give you RPM of or rotational speed of the metering device. Clear?
Yes, sir.
Okay, so this is rotational device of meter RPM of metering device. And next thing is rotational speed of the wheel assuming 10% of skid. What happens in skid is that our vehicle skids is it will cover more than the theoretical distance. Means its actual velocity will be more than the theoretical velocity. So 10% skid means actual velocity is 1.1 times 10% more than the theoretical speed. It, it means this. So what is the theoretical speed? 7 km per hour it is given. So 1.1 into 7 km per hour. This will be actual velocity. So the rotational speed of the wheel is in what they're asking in the rolling radius of the planted is 0.38 meter. Calculate the rotational speed of the wheel. So this section is to find the rotational speed of wheel when rolling radius of the wheel is 0.38 meter. Rolling radius of the wheel is 0.38 meter. This radius is 0.38 meter. and its actual velocity is also given. What will be the rotational speed? Means what will be the RPM of wheel? It can directly be calculated from pi to pi r n. This will become the actual velocity. So 2 pi r is 0.38 into n will be, if you are taking it rotation per minute, you need to convert this in meter per minute. So 1.1 into 7,000 meter by 60 by 60 meter per minute. So here you can get rotation per minute of the wheels. Understood?
Yes, right.
Mm. So this will be the rotational speed of suppose planter and P. So next section is the ratio of metering disk speed of planted disk speed to planted wheel speed. Metering disk and M we have donated denoted and we planted speed is NP. This. So next question is ratio of N means ratio of N by N. That ratio you need to find out. Next question. Here we will solve numericals this week. Next week I will design one set drill and all your doubts also. So next question is what seed spacing is required when planting all rows at 102 centimeter apart if the desired plant population is 6,000 plants per hectare at an emergency rate of 85%. So directly we can do what we have just seen 10,000 by 6,000 plants 6,000 by 0.85 into what is the row spacing 0.04 means 1.02 meter. This will directly give you in meters the spacing. So A part is done.
1.38.
Okay, 1.38 meters. And you can also go from this 4 km per hour side. You will calculate what meter is square per minute. Then what is the seeds in minute? In 1 minute, what is the length it is taking? At this length, how much seeds are being dropped? You divide that length by number of seeds, and you will get a spacing. When you will see lecture, you will understand that this thing is going on there. Whatever I've
So
shown.
second bit to only the unit balance we can do.
Second thing,
No, the second question which we have, we can do it simply by
ah,
uh,
first yes,
balancing the
1.38.
units of the side that.
Yes. 1.38 is the answer. And so second part is if the vertical plate pattern is selected for metering has 16 cells in the seed plate with a diameter of 200 mm. Metering plate has 16 cells, 16 lobe cells. So it will drop how many seeds? 16 seeds will be dropped in one revolution. In one revolution, 16 seeds will be dropped by this planter, by this plate. And its diameter is 200 mm. What is the linear cell speed? We need to find the speed of plate. Linear speed is equal to int d flat. So we need to find what diameter is given. 100 mm means 0.2 meter. We are going meters and m means If you want a meter per second, meter per minute, you can do. If n is RPM, then velocity will come in meter per minute. So we need to find main thing is RPM. What will be the RPM of this planter? How you will calculate RPM of this planter?
Number of revolutions per minute.
How you will calculate?
It's earlier we have found no,
That is different question. Same procedure you need to follow. 16 seats in one revolution. So you need to find that what this planted is, how many seeds are being dropped in one plant here. So 4 km per hour is the speed of planter. So 4,000 meter by 60. This is the meter per minute. And it is covering a row length of 102 centimeter, means 1.02. Means this is meter square per minute. And how many seeds in per minute? This much area, this much area in 1 minute. And how many seeds are being dropped in this area? So in 10,000 meters square, how many seeds are there? 6,000 by 0.85. 6,000 by 0.85. The answer 6,000 by 0.85.
7059.
7059.
70.
Okay. 7059 seeds in 10,000 meters square. So this much meter square, how many seeds? Means 4,000 by 60 into 1.02 into 705. This much seeds in 1 minute.
480.
20. 20 you said, no?
Oh no, 48001. Sir, I have to check. Can you scroll bit up? Okay.
So 7059 in 10,000 meters square. So 7059 by 10,000. That is missing. You will not also can.
That's why I got like 480, but with so now 480 answer.
480. 480 480 by 10,000. 10,000 it is 448. No?
480, huh? No.
It is
Yes,
48.
sir, 48.
Hmm. So 48 seats in 1 minute and 16 seats in one revolution. 16 it is coming. 16 seats it is dropping in one revolution. So for 48 seats, how many revolution it is doing? Simple, it is 48 by 16. This much revolution it is doing. And what we are discussing, it is in respect of 1 minute. So this revolution is taking in 1 minute. So what will be the RPM? RPM of planter plate will be 48 by 16. Is good.
Yes, sir.
So 3 RPM. So 0.5 into 0.2 into 3. This will directly give you velocity of planter plate. So if you have understood this 2 3 questions, all seed drill questions you can solve. One more concept is there. It's also we will discuss here. Then everything will become clear for seed drill. Suppose a horizontal plate planter with 72 cells on a 165 diameter circular plate. The effective radius of the drive wheel is 195 Newton, is 195 mm. 16 tooth sprocket on drive wheel. So what is it is telling? It has planter. It has a planter plate. It has 72 cells on a diameter on a 165 diameter circular plate. And what is the diameter of this plate? 165 mm. The effective radius of drive wheel. Suppose here the drive wheel is there. This drive wheel, this drive wheel has a radius, has effective radius equal to 195 mm. 16 to the sprocket on drive wheel. This drive wheel has 16 to the sprocket. Drives are 18 to the sprocket and feeds out. It is driving an 18 teeth sprocket and feeds out. And a 12 teeth bevel gear on feeds up. This has again a 12 teeth and it is driving a 27 tooth gear on plates up. This is plates up. Here plate is there. This is plates up. And on this plate, on this teeth is this 12 teeth bevel gear is driving 27 tooth plates up. This is the whole pattern of plant. So if you understand this question, all I think section will be revolving around these 4 5 questions. So we have to first find the seed spacing. So we will find seed spacing. Same question is there. Horizontal plate properties which is 6 APM plate diameter 160 mm. And this is assignment question. So we will directly solve this question. So what is here? A horizontal plate planted has 20 cells. This is 20 cells. On circular plate with a diameter 160. The drive weight has an effective radius of 210. The sprocket of 18 teeth sprocket of 18 teeth on drive wheel powers 20 teeth on a sprocket shaft. Additionally, a 14 people gear on feeds after its 29th on plate shaft. For a self-fill of 90%, what is the seat space? So this type of question comes, you can directly relate. So what you will do there, suppose this planter has a speed of NP. NP is plate side speed and NG is ground wheel side speed. So first thing you need to find out is that what is the speed ratio of this seat rim. So NP by NG you need to find out. For that you have studied in detail that NP by NG if it is so this ratio will be opposite side. So plate side if it has 29 thieves it will come in bottom side denominator side and alternate thieves you can arrange on denominator and alternate thieves you can arrange on numerator. So here it will come 14 into 18 and 29 into 20. This will be NP by NG ratio. So what this is giving 14 by 18, 14 into 18 by 29 into 20. It is coming at 0.43. So 0.43 by 1. It means that if ground wheel is rotating 1 revolution, planted seat plate plate was seat plate is rotating 0.43 times. 1 revolution of ground wheel, 0.43 revolution of that seat plate. This thing is the first thing you need to find out. Now we proceed. See what is this cricket wheel has a diameter of radius of 210 meters. So what will it is what will be the circumference of this ground wheel? 2 pi r. 2 pi into 0.2 meters. This is the distance covered by seed drill. This is the distance covered by ground wheel. And what will be the at this when it is covering this distance, how many revolution that seed planter is making? 0.4 revolution. So and in one revolution it has 20 cells means 20 seeds will be dropped. 20 cells into 0.43 revolution into what is 0.20 cells into 0.43 into what is the cell fill. Say it has 90%, means 100% of 20 cells seeds are not coming. Only 0 to 90% is coming. So this amount of seeds are being dropped in this much distance. This distance, this amount of seed is coming. So if you divide this distance by this number of seeds, you will directly get this answer. Did you get Jigyasa?
Yes, sir.
Okay. If you understood this concept, then all the set questions you can solve. So how did we find the spacing?
Answer is
So we can solve this. What you're getting 2.5 into 0.21 by 20 into 0.43 into 0.9. Divide this thing. 17.04 it is coming. And it is 16 point. This is near to 16.8. So we are we have taken something like decimal value. uh, So 16.89 will be the correct answer for this question. Did you understand? Did you understand this question? You solved it by yourself.
Yes, you
You solved it by
answer
yourself.
right.
So next question is, as per BIS for calibration of seed drill using sticky bed method, the variation in quantity of seed dropped due to change in speed as per BIS standards. This also is like theoretical thing you need to remember. The answers which it should not exceed 15% of quantity dropped under a specific speed. And how
Sir,
will
in the final examination, so the questions will be around like the one we are solving here and the assignment or like uh, or from the lectures.
lot of things you said now, it is a mixture of all those things. Direct numerical questions.
But priority to be given which.
It, most of the assignment questions will be there. Maybe 40 to 60% direct questions may come from assignment, and direct PPT questions like lecture questions also will be there. Maybe 10 to 20% of it. And like assessment based new questions from like maybe whole new question will be on 20% maybe. But that also will be based on the numericals which we are solving in lectures.
What will be the percentage of numerical and this theoretical questions like fact based?
I think 40% is numericals, 60% is this question practice.
Okay, so okay.
Next question is curve fit admission unit is recommended for. It is for ground map curve fit admission mechanism. And this question is very easy what we have discussed for whole class. Since whole class, if the effective diameter of the ground wheel is 400 mm, the number of revolution of ground wheel of 5 into 30 centimeters seed drill required to cover 125th effective area. Its effective diameter of ground wheel is 400 mm. Its diameter is 0.4 meter. It is covering a width of 5 into 30 centimeter, means 1.5 meter. And we need to cover 125th of a hectare, means 10,000 by 25, means 400 meters square need to travel. So 400 meters square, what will be the number of revolutions? So 400 meters square, and what is the area it is taking for one revolution? 1.5 meter into its distance in one revolution. Its distance in one revolution is pi a. Is 0.4 times pi. This is the distance it is covering in one revolution into 1.5 meter square. It is covering one in one revolution this much meter square, 400 meters square we need to travel. So 400 by 0.4 into 1.5 into 5. This will be the answer. Is coming. So
See, I'm
the drug revolutions. So this way all miracles are in seed drill. In next lecture we will see how to design a seed drill along with how to design a seed metering drill. If you get routed. So all your seed concept will become clear. So if you have any doubt,
So
yes,
Sidril design, and which one next class we are going to do?
seed petri mechanism design also. Yes. Seed design means all that hopper and all that uh, means furrow opener, along with furrow opener, hopper, everything we will discuss. Power requirement. Seed petri
Okay,
means
sir.
regular exposed length, volume, what it is handling, that we will discuss.
That will be in the like next to next Monday. Like
Next Monday. Next Monday. Next to next Monday is like no, not
9th.
9th. Yes.
Okay, thank you. So mail ID.
Email ID agrisunny AGRISUNNY 98 at the dot gmail.com.
AGRISUNNY 98 @ gmail.com.
Yes. You compile all your doubts, like technical doubts related to that NPTEL course also. I will discuss that with you.
So the technical, okay. Like three only that I don't find that there is actually a noise echo coming of my voice. I don't know. Probably something. I have to
Okay,
switch off my. Then
today I'm using my that's why maybe. Okay, the lecture is over. Next class I will use it. So,
no, if that's the same case with you, like, are you getting my
no, no,
voice rebound also?
no. From my side it is
Okay.
okay.
Otherwise, the recording will be like echo only when I am speaking. Also, like asking something. If,
From my side everything is okay. Like my voice and your voice, it is
okay, sir. I'll compile like three technical issues I had. Like the book, with the book, I didn't file the compilation, and next was the assignment figure method, and the other one was like PDF of the assignment.
and that question also when it's there are mistakes now. Like that figure should be there. One question.
Right.
That
Two,
all
two.
things also you can like you can note it down.
Okay, sir.
And send it to my WhatsApp.
Okay, sir.
Okay, then next week we will meet. Okay.
Thank you, sir. Thank you.